So today I'm going to talk about multi-master. I think everybody, or a lot of people probably saw the presentation by Kisoke about Jenkins, CloudBees multi-master implementation. Kind of stole my thunder a little bit, but there obviously there's this secret recipe. This one is open source, so you guys can download this as much as you want. And what we want is feedback and contributions. Oops. This is let me introduce myself. I'm Khai. I work for HP, but I work out of the Seattle office. And what I do is I actually work on Openstack. Maybe get a show of hand. Who knows what Openstack is? Cool. Okay. So it's a big community. So what I do is I work on I'm part of the team that manages the Openstack infrastructure. So we manage all the builds, the tests, the deployments, all the CI stuff, obviously. And we use Jenkins quite heavily. And I'll go over what the Openstack infrastructure is as an overview, just to give you an idea, kind of like the motivation we had for creating this plugin. And then I'll show you how it works and give you a demo and show you how we use it in production. So does anybody know what Gearman is? Okay, obviously a few hands. So I guess this is very difficult to explain without understanding what Gearman is. So I'll try to give you a kind of a quick explanation of what it is. Basically, Gearman is basically a framework that farms out jobs to different workers. And what you have is there's three concepts in Gearman. There's the client, the job server, which is sometimes called the Gearman Server. And then there are Gearman workers. And we use this framework, and that's why it's called the Gearman plugin. We use this framework so that we can distribute our jobs to multiple masters, Jenkins masters. Basically, what you do is you have a job server, which is just the Gearman server. You create your worker, which is the compute job that you want to do. If you want to do a division problem, you create a worker that does that division problem or multiplication problem. Whatever it is, your worker is the thing that actually does the action. It registers with the server, and then the client sends a job to the server. Basically, it says, I want this division problem to be done. One of the workers wakes up and says, I can do that problem. I'll do it for you. And then it does the problem, and it sends back the results to the server and ultimately back to the client. That's basically it. And it's a distributed framework where you can have as many job servers as you want, as many as workers as you want, and as many clients as you want. And you can have these multiple connection points to each one of these pieces. And that's just the explanation of Gearman, just to kind of give you an idea of what it is. And I'll go through it and how we use it later in the talk. So let me just give you an overview of OpenStack here. It's basically the open source software for building private and public clouds. So if you had a data center and you wanted to run it like an AWS data center, you could use OpenStack because it's free. You can download it. You can even actually run it on your desktop if you want. You just obviously need a lot of memory and horsepower. There's different. So this picture shows different parts to OpenStack, but That's not really true. There's not just these three parts to OpenStack. Those are the main things. There's compute, network, and storage. And what you see is OpenStack is made up of a lot of projects. And there's the server-side projects, there's the client-side projects, and there's always more coming online. And there's one infrastructure to service all these projects. So you know, all these are in our Git repository. We do the builds and run the tests in all these. So OpenStack is obviously open source software, and a lot of the contributions are coming from companies. And these are all the different companies that contribute, not only, and plus, you know, other smaller people or companies as well. These are the big ones. You got, you know, Red Hat, HP, IBM, Mirantis, Rackspace. I think a lot of them are here. But basically, what this makes up is a lot of contributors. And when you have a lot of contributors, right now I think it's probably averaging 700 active contributors. And an active contributor, I think the definition is has submitted a patch within 3 months or something like that. So that's a lot of contributors. So this is a very large project, I think. And not very many people run projects this large, I think. So that kind of sets us apart in what we do. So when you have a lot of contributors, you have a lot of patches. And what this graph shows is the number of patches we have per day. So I took this kind of snapshot of this graph maybe a month, maybe 2 months ago. It was like on one of our milestone releases. And if you look at the peak around 9/27 there, it's 10,000 jobs, or those are builds per day. So over 10,000 builds per day is what we run on our infrastructure. That's really big. I saw the keynote by Kusoke, and said he was doing 62 jobs a day, or builds a day. So this is quite a large scale. So I'm just kind of giving you this information just to let you know, like, you know, what's kind of like at the scale we work in for this project. So this graph shows you the number of slaves that we use. At the peak, see the numbers on the left-hand side are the actual number of slaves. So at the peak, we're using almost 300 slaves for our builds. That's to keep up with this 10,000 jobs a day. So that's what we have to do. And these are, well, this is one of the reasons why we had to go to multi-master. We were using the single master and trying to scale up. We're probably doing 30, I'm guessing 50 gig machines, 50 gig, 16 CPU machines, and they were not keeping up. So we could not scale up anymore. And we also ran into the situation where we were adding so many slaves to our master that the connections were not reliable anymore. So and I think this is a bug in Jenkins, where you get to a certain point of slaves, the master and the slaves aren't communicating anymore very reliably. And I'm hoping the scalability problems or bug fixes that Kosuke mentioned earlier with the number of threads, reducing the number of threads helps that. I'm guessing it will. So for our project particularly, these are some of the tools we use, not all, but just to give you an idea of our environment, we use Git for our SCM, Garrett for code review, so, and obviously Jenkins. So did anybody see the mobile application lifecycle? Yeah, that was actually cool because we actually use that lifecycle. So we have Git, Garrett, Jenkins, but we add another thing called Zuul, as you'll see here, and that's very important because Zuul is a very important tool because it allows us to run multiple patches, multiple changes in parallel. So we don't have to wait for one change to go through the system to make sure it works, to run another change on top of that, because they might be dependent on each other. So Zuul is another big reason why we have to scale out. It was dumping too many jobs to our master, and our master could not keep up. So now we have Gearman. We didn't have that before. We have this node pool app, which spins up nodes, what we call dev stack nodes, which are like temporary virtual machines. They get spun up, do the build or test, and then get shut down. So just to give you an idea of all the tools we use. And like I mentioned before, Zuul, how we run our CI is a little bit different than I think most people run CI. Like when the typical CI installation is you upload a change, it runs through your build and test, it fails, and then you have a broken master or tree. So what we do is we do this thing called Preemptive CI. And what we do is we test before that gets committed to the master. So somebody uploads a patch, we run a test, or we run a build test to make sure that it passes before we merge to master. So nobody ever will download a failing master. And Zuul is the thing that kind of makes it possible. And actually, this guy, James Blair, he gave a talk at the last Jenkins conference about Zuul, and that could be an entire talk in itself. But basically, that's what it does. And he's actually been very instrumental in implementing the Gearman plugin as well. He did a lot of the work as well. So to give you an idea of what Zuul does, I don't want to go through his whole talk, but I'll just give you an idea of why our Jenkins server was getting overloaded. And basically, what you're seeing here is you may have 3 patches that come in to our system. What happens is what we do is we run all these patches in parallel. And then you'll see that maybe patch 1 and patch 2 passed, but patch 3 failed. We know that patch 3 failed, but why is patch 4 failed? The question, could it be that it's failing on its own, or could it be that patch 3 caused it to fail? So what Zuul does is it does a lot of this rebasing. So what we do is we run another test with 4 rebased on top of 1 and 2. So now you have to see if that combination works. And if that passes, then we can merge 1, 2. We can discard 3. We know 3 failed. And 4 passed, so now we can merge 4. So this is, a kind of like an optimistic algorithm where it assumes everything's going to pass. And that's your best case scenario. If everything passes, you've got 4 parallel builds going at once, and they all get merged. And that's actually the typical case. So we get a 4x speed up. Because, well, it probably depends on at the nx speed up, because it just depends on the number of patches. If it fails, then obviously we just throw it out. But the thing we want to optimize on is the runtime or the throughput of these builds. And if we didn't do that, it would take us days to run all these, or months or whatever, to run all these builds. So this is what we had before the Gearman plugin was in place. We had our Garrett code review, which basically generates events. So one event could be a patch was uploaded to Garrett. Zuul then takes that patch, sends it to Jenkins. Jenkins would run it on one of these slaves and send the results back to Garrett. So one thing that's kind of unique about our project is we don't use the Jenkins UI very much. We don't even look at it, actually. We only really use it to see if once there's a failed test or build, we'll go to the Jenkins logs. But otherwise, we don't even look at the UI. So the UI is kind of not important for us. What when we develop for the Openstack project, we look at the Garrett code review page. That's kind of our thing that tells us what patch we have, what the status of those patches are, whether the build passed for those patches, whether the build failed for those patches, and we can even go to the logs if something failed, those patches through the UI. So the Jenkins UI isn't really important for us. So you can obviously see the problem with this scenario. We had this Zuul client that was sending way too many jobs, or it was sending a bunch of jobs, builds to Jenkins. And Jenkins basically, in this scenario, was getting overloaded. The queue was just getting backed up. So one of the problems is scaling we had. The other problem we noticed is, obviously, you can see the redundancy problem. I don't know about you guys, but every time I install a plugin, I'll probably have to restart Jenkins a couple times, right? Just to make sure that's working, make sure the version's working with the current version of Jenkins. And we had this whole orchestration that we had to send out an email, wait for people to acknowledge, make sure everybody got the email, and then we take it down for a certain number of time, bring it back up. And that just even slowed things more down because we had all these jobs backed up from Zuul getting all these Git requests coming in. You know, you have on average, I'm guessing 7,000 events or builds that you want to build a day. Our system just wasn't keeping up. So what we wanted to do, obviously, was add more Jenkins masters so we can add more Jenkins slaves. And we get that redundancy as well. So now, this is what we have. We added this Gearman Server between Zuul and Jenkins. And now we have 3 Jenkins masters in our system. I think each Jenkins 01, I think, has like some slaves that are static, so those never get destroyed. Those are all VMs, but they don't get destroyed. Jenkins 2 and 3, what we do is we attach all the slaves to the 2 and 3, and we have about, well, I think about 150 slaves each attached to 2 and 3, so that those slaves usually will service all the jobs. So this is kind of what it looks like. If you look at the flow, so we have this Gearman client, which essentially in our system is Zuul. But you can create your own client. It's agnostic, and you can do it in any language you want. It's one of the nice features about Gearman. This client sends a bunch of build jobs to the Gearman server. The Gearman server basically puts it in its queue. And then we have over here the Gearman workers. The Gearman workers work as a plugin to the Jenkins master. So you install it as a plugin, and then it runs. It basically attaches to this Gearman server and says, I can run these builds. The same with Gearman workers in master B, I can run these builds. Yeah, go, question.
Is the Gearman server just a Jenkins server with the Gearman plugin added? Or is it a completely different code base?
No, the Gearman server is not Jenkins at all. Is that your question?
Yeah.
It's not Jenkins at all. It's a separate server.
So we can't run any Jenkins jobs itself. No. It has to delegate it.
Yeah. So that's just the architecture of Gearman itself. Yeah.
Just a quick question. Now you have multiple Jenkins masters. Now, how the jobs are synchronized between them? So the same job will run at some point at A,
yes.
at some point at B, at some point at C. So how do you synchronize the job between these 3 masters?
Synchronized. I think they're just independent.
Because like the jobs are like, for example, running a Maven with unit test with whatever. So it's a stateful. So the user will run to master A, and let's say master A goes down. He wants to know what's the progress to run to master B, or it's going to be independent copies of that. There's no relationship.
Well, our tests themselves, I don't think there's dependencies in the state of the test.
So there's no synchronization between the jobs. So let's say I have 10,000 jobs in A, and let's say these don't exist in B. So let's say A's go down. So is there any mechanism to sync the ones in A inside B?
No.
It's not real open.
But the jobs don't get lost, I guess.
Yeah, they'll be reloaded.
Yeah.
Back, but they won't be available until you restart it.
Yes.
And one more thing. Now, in terms of the slaves, now you said each one has its own set of slaves. So the slaves are not shared. between the three masters. Each one has its own state.
Yes,
Okay.
it's true.
So is it possible to kind of split certain jobs for certain like masters?
Yes.
And another question is like, is it possible that when master finish job, that it trigger another job through the Gearman server, or it's actually run all like sequence of like jobs on the same like master?
It can.
What's the question?
Oh, sorry. Yeah, actually, he asked a few questions. So
the first one is like, can you split jobs between different like masters?
Okay, can you split jobs between different masters? And the answer is yes.
I mean, like dedicated job for a specific master.
Can you dedicate jobs to certain masters? And the answer is yes. And you do that through the label system, just like you do in Jenkins itself. Does that answer your question?
Yes.
So,
The second
yeah.
question is like, can the master, if we have like, after we done one job, if we have to do like the second one, we should trigger the second one. The second job runs locally on the master, or it actually goes back to the Gearman server and then spreads around to like.
okay, so the question is, do dependent jobs run on the same master, or does it run on a different master? Is that the, and I would say to that question, it probably depends on the dependent job and how it's configured. So if you have one job that ran on, oh, sorry, hold on. So, if you have one job that's had a Gearman worker in it, let's say Gearman Master C, that says, that first job, I can do this job. I can run this job. And then on the dependent job, if you had a label that's only set to Master B, then it would only run in Master B. Because this Gearman worker has a label on it that says, I can only do these jobs. And if that dependent job happened to be to match the job that the Gearman worker knows how to do, it will do that job.
And if there's no label, it will pick random.
Yes. If there's no label, it will just run on any master. And that mirrors how Jenkins works through the label system. Right? And I'll cover that in a little bit. Go ahead.
How do you mirror the configuration across the different masters?
Okay, that's a good question. How do you mirror the configuration between different masters? What we do is we use this tool called Jenkins Job Builder. I don't know if anybody's heard of that, but basically it automates building of Jenkins jobs, or another word for jobs in this context is projects. So that's how we automate that process, and that's very easy for us to do.
So this one like a script CLI with all the project files, and we just do a CLI them on the second master. So they'll be mirrored.
Yes.
But they will be from scratch. They don't have the state information. We'll do like a new job script.
Okay, so the question is, do you run scripts to create the mirroring? And the answer is yes, that's what we do.
They will look like a new job created.
Yes, and they will look like completely independent jobs on the two masters. Yes.
How do you do with reporting and analytics across the getting those statistics and things like that?
Okay.
Masters.
Sure. Okay, so the question is, how do you handle logs or reports and analytics from the different masters? Okay, so the answer to that is probably out of the scope for this talk, because we're working on something that does, which uses an Elasticsearch cluster. And what we do is we index all the logs into this database, Elasticsearch database, And what we do is we put a UI front end on it that allows you to search all the logs, all the log information. That's in process right now. We're hoping to get it working probably within a month or pretty soon, actually. Yes?
For a given commit, which job is going to trigger? Is that defined by the Gerrit?
Sorry, what was the question?
For any given commit, what job needs to be triggered? Is that configured somewhere or is it managed by Gerrit?
So the question is, how is the triggering done? Okay. I guess maybe we'll go back to this slide. That is the question. So how the triggering is done. You see the Gerrit code review server right there? So Gerrit sends events on anything that happens in Gerrit. So maybe it's a new patch, maybe it's a comment that got added, maybe it's an approval that got created. All those events, Zuul understands those events. And then once you get an event, you fire off a build, basically. Yeah.
What's the difference between Zuul and Gerrit trigger plugin?
So the question is, what is the difference between Zuul and the Gerrit trigger plugin? So my answer to that is they probably do the same thing. Excuse me?
Does Gerrit provide the dependency mechanism by default? I think
Dependency mechanisms? Yes.
Zuul does the dependency mechanism and Gerrit doesn't.
Yes, that's you. So I should go back and say Zuul is probably a little bit more advanced than the Gerrit plugin, Gerrit Git plugin, in that it manages the dependencies of the commits. So it does the same thing as the Gerrit Git plugin, but more, I would say. Yes?
And does this also assume that all the job submissions are automated, right? And so there's no front end for the users to initiate or schedule a job?
That's correct. So the question is everything, all the job creation automated? Yes, that is correct. What we do is we have this Puppet Master configuration, Puppet Master agent configuration. And what we do is we check everything into our Git repository. So we make changes to YAML files. And those YAML files basically are Jenkins job builder configuration files. So they're defined in those YAML files, what projects get into Jenkins. So it's completely automated. And every time we make a change, we send a patch up through Gerrit, which get reviewed. And then that doesn't get merged until an approval happens. Question?
How do you decide how many masters you want to have, or how you want to provision machine for big machines versus small machines? What
Okay,
have you learned about that?
Question is, how do you know how many masters that you want?
What have you learned about provisioning small machines versus multiple machines if you're going to distribute it?
So my question to you and probably is that I haven't been doing much of the provisioning. So I haven't actually done that part because I'm not one of the core infrastructure guys actually right now. So one of the core people do all the provisioning of the machines. And I think basically what we want to do is keep up with the number of commits that are coming in. So I think it just basically depends on what the load is there. Obviously it probably depends a little bit on how long it takes your jobs to run as well, but there's probably a lot of factors involved with that decision making. So again, this is what happens. Now, what this shows is basically Gearman sending in a bunch of build jobs, Gearman queuing those jobs up, and this is a FIFO queue. And these workers basically are saying, I can do this job, I can do this job, I can do this job. And what this worker does is, what we've done here basically is shared that queue between multiple Jenkins masters. So we've essentially kind of replaced the Jenkins master queue with one master queue. And now, that's how they interact, or that's how they coordinate their job executions from this queue. Yeah?
So the bucketing is label based. How is the Gearman server made aware of the relationship between the job triggers coming in and the label?
Okay. So the question is, how is the Gearman server aware of where to send the jobs to? Is that or? Okay, so.
Because it's label based.
Yes.
So I'm wondering how it understands the correlation.
Yeah. Good question. So let me see. So I think you know that how Gearman works is that the workers register to the job server. And how it registers to the job server is using an ID, or a function is what it's called. So like, when you say, worker here does all addition, worker here does all division, your function ID might be, I can do divide, I can do multiply, whatever, right? So that, we basically took the labels and put them there.
So you control the weight the label for.
Yes. Yeah, question?
Is there an import function in Gearman to take job definitions from Jenkins and turn them into Gearmanese, or do you have to manually redefine all of your jobs in Gearman so that you can then delegate them to the Jenkins?
So the question is can you create Gearman jobs?
Definitions from Jenkins job definitions. Can I just import them and have Gearman figure out, translate the representations?
Okay. So can you
See,
take?
if I have an investment in Jenkins across, say, several servers, and now I'm going to, instead of manually managing those, I'm going to consolidate in Gearman. Well, I'd like a simple way of just pulling all that information into Gearman, and then saying, okay, now let's do the Gearman specific part as to how to parcel these out.
Okay. So I'm having a hard time rephrasing your question, but I think the answer is that the Gearman workers create the ID that's needed to run the job, to send the jobs to the right place.
So how do you see those things through Gearman?
Oh, they're what do you call them? They're function registrations, basically. So the way to see them actually is you can there's a port that you can SSH or telnet to that you can list all the function registrations. Here's an example. Maybe I can show this.
Is it that the workers register themselves with Gearman? Is that how it works?
Yeah. Basically, the workers, when you start it up, they register this function ID.
Oh, okay.
And then that function ID says, I can do this work.
Oh, okay. So that's how Gearman learns about it.
Yeah, that's how the master knows which worker can do what job.
So that means if a new Jenkins, new job description, new project is created, Gearman automatically knows it from the worker.
Yes, so if a new Jenkins job is created, Gearman automatically knows about it. Yes, that is correct, as long as the project is online or whatever, active. because you can turn it off, right? So, so I'm running out of time, but basically, let me show you this. So this is another view. What we do is we put so these pieces are the Gearman pieces, and every execute, this is, you probably understand this from Jenkins, right? Master, slave, slave, executors per slave. It's got this architecture. But what we do is we put the Gearman workers on. We run a Gearman worker thread for every executor. So it knows about that, it knows it can run that job. Let me see. So let me show you a demo, since with the time I have left. So I have here 2 Gearman masters, and you'll see that they have one. The master has an executor, and it has 2 slaves, each with 2 executors. Now I have this simple client, my Gearman client, that when I run, it basically sends this information to my Gearman server. Basically, this is the function, which is called build Guava. Guava is actually the project name. As you can, I'll show you again. So you'll see here that this is Guava is the project name. So now if I run that, and I'm telling it I want to run it 50 times. It sends it to Gearman, and now all these jobs get started here, and it just runs through. And so one master knows I can run Guava. The other one says I can run Guava. So it just says, give me all your Guava jobs, and it just runs them through.
So now each one is running the same jobs.
It's running the same jobs 50 times, basically.
Each one gets roughly 1 time.
Is there any load balancing between the two, or how does it happen?
Well, so the load balancing piece is that this is serving that same queue, so it's just picking up jobs. So if it has no more executors to service that job, it just doesn't do it anymore, and some other master will pick it up. Does that make sense? So here, let me go back to this slide, and this is probably, so Master C says, I'm servicing all these jobs, but I'm out of capacity. So now, B says, oh, I have capacity. I'll service the rest of those jobs. Or A will do the same thing. Right?
And the capacity is preset somehow, or is it
Just depends on the executors that can run the jobs.
Okay.
Yeah.
Does the Gearman server have a UI or a home page or a web page that you manage it through? I'm not clear on how you control the Gearman server.
The Gearman server, what I run is the Python Gearman server, and actually Jim Blair created that.
It's just headless.
It's headless, but there's another Python project out there. I think I've used it before that puts a web UI on top that shows you the jobs that are running and how many workers you have and all that stuff. Let me show you what it looks like in my demo. Let's see. So here's kind of what it looks like. You'll see these build Guava. That's the label that's on the Gearman worker. These are worker registrations. when I passed in that function ID, it's mapping to that. And so this is just a basic telnet connection. So if I go and I run that again, Guava. So this status is an admin command that just tells me what's running, and I think it has a bug because it should show me that some number of jobs are running, but it says 0. Oh, I know why. I have to keep the connection open. Let me try that again. So you see that 50 right there at the bottom? That means there's 50 jobs in the queue it's trying to service, and that should go down. Not yet. I think it's still servicing now.
Is there any security on that connection?
So right now, there's no security for Gearman. So the question is there any security? Gearman does not have security built in. I think that's a feature that's getting added. Although how we secure it is, you'll see that there's only one connection, one point between the client and the server, the Gearman server. The Zuul is our client, Gearman's our server.
Yeah.
So we just do the IP security thing. We lock it down.
You check Zuul's IP address
Yeah.
on an ACL.
Question?
How does all those jobs relate to version control? How do you know you're building exactly the same thing?
Let's see. I'm not really sure I understand the question. Could you maybe rephrase? How do I know I'm building the same thing?
All those jobs are related to a particular check-in, right?
No, those are just jobs that I manually kick off, but they could be from a check-in, yes.
Right. So how is the relationship? If they are all related to one particular check-in, how do you make sure that they are actually looking at the same source of truth?
Okay, so the question is, how do I know that my build is building from the right checkout? Is that the question?
Yes, assuming you have a pipeline of jobs.
Yeah. So again, that's what Zuul is all about. Zuul manages all that for us. So again, this demo of the patches being dependent on each other, so Zuul manages all that. We rely on Zuul, our client, to do all that for us. Yes, question? Yes, good question. So the question is, how do you pass in parameter variables to the build? So the way you do it is you can, well, how we do it is, like with my client, I can pass in a param, and that gets propagated through to Jenkins. You'll see like these jobs here, they have some param. These are default params. And if we look at the job, and you look at one of them, you look at the param, this should match. So what I did is I passed in this parameter to the job that I built. And that showed up here in Jenkins. So passing in params is possible, and that's how you do it. And in our system, Zuul does that. It passes in all the params from Gearman.
One more question now in your implementation. So are you just depending on Jenkins CLI, or are you have extended the item listener as a key?
Okay, so the question is, are we just using the Jenkins CLI, or have we extended the item listener? And the answer is we've extended the item listener. Question?
I'm sorry, we're out of time.
Oh, sorry. About time you can catch up. Thanks for attending my talk.